Hello folks, good to see you. Today we're starting a new unit. We're going to start our static and electricity units, kind of two parts. The first part of this unit is a statics unit with a small test, and then we have an electricity and current electricity, and sometimes we combine them, so we'll just kind of play it by ear and see how that goes. Hope everybody's doing well. If you don't have the package for the statics unit yet, it's a booklet that looks something like that right there, you could see. Now, I would have told you where you could get those. You could pick them up at the school or arrange to pick them up. Or, like I said, there's a digital version like that one right there in the classroom that you can just you can scroll through pretty easily, right, and do what you need to. So you can use the digital version if you need to, and you can use a paper version if you want. And I would suggest getting that hard copy or printing out the digital version as we get a little further on, because some of the sheets you're actually going to want to use. This one you could just do on a separate piece of paper and write out the answers if you need to. If you don't have the booklet, write the answer, write the question number and the answer out, and just improvise and get that to me. So today, just to summarize what we're going to be doing, is we're going to watch the video of me, and you can pause that whenever you need to. If you need to pause to write notes, just pause it on your own. This is you running the show now. So you can pause it and watch the video, make notes. So when I make a note on here, right, if I make a note down here, you make a note down there, right? And you're going to do the sheet. What do I mean by the sheet? I'm talking about this sheet here called electricity assignment. We're going to work on that in a little bit. And you're going to do that. Now, if you don't have the sheet, just write question 1 and the answer, question 2 and the answer, question 3 and the answer on your same sheet that you took notes on. Just take your notes and then do the questions on a sheet and then submit a picture of that to me and you would be considered, right? So watch the video, make notes, do the sheet, submit the work. Now what do I mean by submit work? I mean just send me a picture of your work to this assignment in the classroom. And after that, watch the video of Julius Sumner. He's one of my like kind of science heroes. He's kind of like the Bill Nye of Australia a little bit further back. He's a mix of like Bill Nye meets Einstein, and he's really a character. Fun fact, Julius Sumner used to be on a TV show in Canada for a few episodes as a mad scientist in this show called The Hilarious House of Dr. Frightenstein, which was shot in Hamilton, Ontario. And it's a really kooky, weird kind of horror kids comedy show. Very strange stuff, but it's got a kind of a cult following. Anyway, let's get down to it. So what we're going to do today is we're going to learn about the history of electricity. And like, I know it's kind of boring because I teach you all these things that are like wrong, right? Like we did in the last units, we always heard they originally thought this, and then another person thought this, and then another person thought this, and then another person thought this, and this is where we are today. But that's what science is about, folks. It's about learning and taking theories, testing them, adapting, proving them, correct or false, modifying, improving. Science never sleeps, right? We're always improving, we're always learning more. So we're going to learn a bit about the history of what people thought about electricity, right? So if you want, you could follow along with the documents here. That's what we're going to be looking at, and I'm going to try and put it down here as well, but I'm going to write notes down there, and you'll write the same notes that I do. So let's just take a look at the first slide here. I'm going to use the booklet for a second. Actually, no, I'm going to use the Mac. All right, cool. So if you're looking at this, you can see right now, what was the idea of electricity? How was it created? In the 1600s, they had something called the one fluid model. So that's going to be the first thing we're going to make a note about right away. William Gelbart suggested that electricity was a fluid that could flow between objects. Benjamin Franklin explained that there was positive and negative charges due to that fluid. That's a little weird. So they thought electricity was a fluid, and it was just one fluid. And the amount of fluid you had determined whether you were positive or negative. They were wrong, but it's a start, right? That's the best they had at the start. So let's take a little bit more of a look at that one fluid model here. Let's just see. So now, this is what they believed. They thought that when you lost a fluid, this magical electrical fluid, you became negative, and if you had too much fluid, you became positive. So if you had the right amount of fluid, you were neutral. If you lost fluid, you were negative. And if you had too much fluid, you were positive. So that's going to be our first note. So let's just write that down here. So I would write lesson 39, notes. Sorry, I'm going to remove that for now. It's a little rattly. lesson 39 notes, and then I would write one fluid model, electricity was a fluid. Too much fluid. If you had too much fluid, you were positive. If you had too little, you became negative. Neutral equals balanced fluid. And you can write 1800s approximately. Oh, sorry, 1600s. 1600s. There you go. So that's what you should write. Now, if you need to, pause it right now and take that down. I'm going to keep moving, so if you need to write that down, you can write what I did and you can pause it. All right. Now, of course, after the one fluid model comes the two fluid model. And this is getting a little closer to reality. This is actually a little more kind of what we actually use now. So let's take a look at the two fluid model theory here. Right? So then comes along the two fluid model. This model used two types of fluid. One of the fluids was thought to be positive and one was negative. Now, okay, this kind of gets a little tricky because if you got this negative fluid, well, if you lose some of your negative fluid in their theory, what would you become? You'd become positive. But there's another way you could become positive. You could also gain some positive fluid. So they thought you could either, to become a positive object, you could either lose some negative fluid or gain some positive fluid. Likewise, they thought there was a positive fluid that you could gain or lose to make you positive or negative. So let's just take a look at this two fluid model a little bit here. Let's see this. So they thought one of the fluids was thought to be positive and one of the fluids was thought to be negative. An object could become positive by gaining positive fluid or by losing negative fluid. That's pretty cool. Similarly, they thought that an object could become negative by losing some positive fluid or gaining some negative fluid. Yeah, they were wrong, but this is getting a little bit closer. So now we're going to write down here a summary of the two fluid model. And remember, you need to do this. This is part of your assignment. So I would write two fluid model. There was positive and negative fluids. To become positive, lose negative fluid, or gain positive fluid. Remember, they were wrong, but that's okay. And then you could also say to become negative, lose positive fluid, or gain negative fluid. So once again, they were off, but that's okay. Make sure you're getting those notes down. Pause the video if you need. So now we're going to move on a little. I'm just going to flip through my book. Oh, now if you've done the chemistry unit, this is easy. If you haven't, don't worry because we're just touching on it. But coming up next, you can see here, in 1897, Thomson discovers the electron, and this came up with this particle theory of electricity. Important definitions. Electrons are negative, protons are positive, neutrons are neutral, and an atom is the smallest matter that consists of electrons, protons, and neutrons. This is pretty much a review at this point, but you need to know that. I believe, oh, there was a problem loading the page. Let me just reload that for you for a second. Sorry about that. There we go. And that is the particle model of electricity. When two objects are rubbed together, electrons are moved from the atoms of one to the other. And if you lose electrons, guess what you become? You become negative. So look up here. Let's get this straight. So what you need to know from those slides is that the particle theory says no matter what you do, if you take two objects, I've got a glass rod and a plastic bag. I don't know yet because I haven't consulted my chart, but we will have that soon. When you rub two of them together, one of them, just by rubbing, will lose electrons, and one of them will gain those electrons. And there's a chart to tell you which materials will lose and which ones will more likely to gain. That's called electron affinity. We're going to get there right away. But if I rub these, in this instance, this glass rod has actually lost some electrons to this plastic bag. How does this apply to what we were just doing? Well, if this loses electrons, it has become a little bit more positive. This is a positive rod now. And this bag has actually become more negative. Now, you could do that with other things. The things that we use in this class for all of our experiments, we are going to use plastic bags with a glass rod to make a positive glass rod. You need to know that. That's something we're going to go through a lot. I'm going to help you with the notes right away. Plastic bag plus glass rod equals positive glass rod. The other option, and I hate using this one because I'm actually slightly allergic to it, but I've tried to find synthetic versions and it doesn't work. The other option is to take a rubber rod and animal fur. And if you do this and you rub the rubber rod, the fur loses electrons and the rod gains electrons, and that's how you make a negative rod. So fur plus rubber equals negative rod, and glass plus plastic equals positive rod. So that's something we're going to need to know. So let's take a look and think about how this would apply to what we're doing today. So let's look down here. Okay. You could write what a proton is, and I'm just going to write positive. Neutron, no charge. Electron, negative. And this is important. Only electrons can jump between objects. That's really important. See, what I'm saying there is that electrons are the things that if you're rubbing things together, they can go from one object to the other. You could still make something more positive or negative, but protons will never jump from one object to another. So as you get further into assignments, and I get you drawing charts of things transferring charges, if you are drawing a chart where protons are jumping to another object, you've made a mistake. Protons never leave an object. Protons can move from one side of an object to another. They can move within an object, but they can't jump to another object. Only electrons can do that. So if you're working on stuff in the future, that's a great rule to remember. If you started having protons on a rod and they jump to something else, you have made a mistake. It's always the electrons that move, because electrons are in those valence shells and they're easy to move. So that's what we're talking about there. Now I want to add a couple more things to your notes here. So you've got what I've done there. I'll just put that down if you need to pause it to catch what I've done. And now I'm going to move on with a little bit more. Particle theory. I'm just writing this very point form. Equals rub two objects and one will become positive, and I'll put under lose electrons, and one becomes negative, and that's going to be the one that gains electrons. Sorry about that writing, that says gains electrons, and if you want, you can pause it and write there. In our class, you can write fur plus rubber rod equals negative rod. And you can also write plastic bag plus glass rod equals positive rod. And I will write again, only negatives can jump between objects. All right. I hope that is coming along. And if you need to pause it to write that down, this is part of your assignment, is taking these notes and showing me you've done them. So please work on that. Now we'll come back here. Oh, I think we've gone through most of this, but let's just take a look at these notes for a second here. The particle model of electricity states when two objects are rubbed together, electrons are removed from the atoms of one object and moved to the second object, and that object that gains those electrons will become negative. That's pretty self-explanatory. The first object is positive because it lost some electrons. Now let's just think about that. To make something positive, remember, only electrons can jump. So if you want to make something more positive, you actually have to remove some electrons through friction. If you want to make something more negative, you need to gain some electrons through friction, because electrons are the things that are moving. You want to become more negative, you need to get more electrons. You want to become more positive, you need to lose electrons. Electrons are what move people. Oh, sorry about that. We got a bell going. Excuse me, but this is a good time. I'm going to take a little pause for a second. We've already got a couple minutes in, about 15 minutes into this video, so I'm going to take a break, and I'm going to work on the next package. So give me 1 second, and I'll be right back. And make sure that you have that second page of notes. And then we're going to talk about how static electricity can be manipulated depending on the materials and how you could transfer them and make charges. So we're going to learn about electron affinity. We're going to learn about conduction and induction, generally speaking. And then we're going to move on to some more kind of cool stuff coming up right away. So give me 1 second and we'll be right back.